Hello, today we're going to be talking about writing Google tests for UEFI. I'm Vivian, I'm part of the core UEFI team. I'm going to be giving a little introduction to Google Tests, go over its features, how to create a new test, run one, and then go over some file location rules. Host-based unit tests are run without hardware as part of the PR process. Previously, Project Mu was using something called Framework for host-based unit tests with mock support from Cmocka. Moving forward, we'll be using GoogleTests with Gmock. This presentation will cover getting started with GoogleTests, and a part 2 will be made to go over consuming existing Gmocks and creating new ones. So here we have the first submodule we need in Mu Base Core, the GoogleTest library. This picture is just for your reference so you know where to find it. Our primary goals in this transition are better code coverage, not just more tests, but tests that are more concise, logical, and better documented. Standardized host tests and mocks for consistency, and to make host-based unit test creation easier and faster. We also want to foster good programming practices like writing code that is modular, easy to understand, and is testable. This will improve the overall quality of the code base. Here are just a few of the improvements we have moving over to GoogleTest. We don't need extra code to register each test case, so it is simpler, cleaner. We can configure timeout support so the tests don't run indefinitely. There is a handy VS Code extension that I'll show later that allows for easily running and actually debugging individual test cases. There are parameterized and typed tests. We can group together test cases that share the same variables and even have a setup function to reset any values if needed. This is done through the use of C++ classes, as GoogleTests are written in C++. Moving on, in this example, we're creating a host-based unit test for the config knobshim Dixie library. First, we need a new folder named GoogleTest inside the libraries folder. In this example, there is an existing old framework test, so our GoogleTest folder is on the same level as the unit test folder. Inside our new GoogleTest folder, we're going to need two new files, our INF and our test source file. These should be named as the library name with GoogleTest appended. Here's a link to an example. I will be sharing these slides so you can click all the links. So what you can do is use these as a reference or even copy what you need out of them. For the INF, you can essentially copy the example file, taking care to replace the commented file name, the base name. You can generate a new file GUID, and under packages, instead of setup data packages deck, use whatever package your library is in. For a C++ file, we can just put in a dummy test that we can run to verify we've set everything up correctly. I can share that code snippet at the end as well. You can see the structure of the file will generally be your includes, with an extern for your C header files, your tests and any classes to group those tests, and your main function to call run all tests. Next step, add the new test INF to the package host test DSC file under components. If a host test DSC doesn't exist for your package, you can create one and use a package like MDE package for a model. Moving on to running the test, I personally recommend getting the C++ TestMate VS Code extension, but it is not required to move on. We'll build from the command line using Stewart CI build. You can run an individual module using the build module equals and giving the path to the INF, or you can always build all test modules. To run the test, you can directly run the executable found in the build folder under your package/host test/noopt/x64/your test name. Or if you have the VS Code extension, you can have a GUI to run the test file, with the added functionality of being able to run individual tests within the file and debug them. With whichever method, for now, we're just going to make sure that all our tests pass. Some guidelines when building up our host-based unit tests. So what to cover? Right now we're prioritizing external interfaces like protocol functions, library functions, and any functions with EFI API in the function declaration or definition. Tests should be isolated, not dependent on any other test or service. That's why we'll be introducing mocks in the next video. We want to test thoroughly. So for example, if we're testing a library, then every function in that library's header file should be tested. This means positive and negative scenarios, expected outcomes, as well as edge cases with error conditions. We also want to use meaningful test names, keeping them descriptive to indicate what exactly is being tested. I did go over where to create these new files, but I want to clarify the example I was using was a test for a specific implementation, which is why it should be scoped to the implementation directory itself in a GoogleTest subdirectory. There is a special case where if you're creating a test for an interface agnostic to a specific implementation, then it should be scoped to the parent package in a test/GoogleTest subdirectory. You can see an example in the MDE package. Here are some useful resources like the GoogleTest documentation and some examples in MuBase Core that show off a lot of the different things you can do with test groupings. The next video will describe how to create Gmocks, but we'll wrap up here for now. If you have any questions, please feel free to email me or my team. Thanks.